Let's start by simple examples where we just want to find the shear stress inside a circular rod that is submitted to one torsion, one torque. So the formula for the shear stress are tau equal T time rho divided by J. T, it's the torque in Newton time meter. Rho is the distance from the center, from the centroid, so that will be in meter. And J, that's the polar moment of inertia, that will be in meter fourth. As you can see, the formula for a disk is pi divided by 2 times C4, C at the fourth. C is the radius. Okay. Um, Make sure that we have the correct units. And again, those formula for the polar moment will be given. It's a little bit like the I. You remember the moment of inertia, mass moment of inertia? Depending of the shape, it's a different value and it's provided. So let's find the shear stress at point A in that rod. So we will find J first. And J, it's a property of the surface. It does not depend on which one we are looking at. It's just the property of the surface. So we have J equal pi divided by 2 times C. So C here is 75 millimeter, the outside diameter, like the largest diameter. So 0.075 at the fourth. So J equal 49.7 times 10 minus 6 meter fourth. It's usually very small value depending of your units, but it's small. We like to use 10 minus 6 engineering notation. Tau now equal T, let me rewrite the formula, T rho divided by J. Okay, T in Newton time meter, so it's 5 kilonewton time meter, so it's 5,000 Newton time meter. Rho in millimeter, rho, that will be the distance from the center to A, so that's 0.04 meter, and divided by J, that is our 49.7 times 10 minus 6. So we have tau equal, we get 4.024 times 10 at the 6 Pascal. That's equivalent to 4.024 megapascal. So Newton per millimeter square. So not difficult, but just be careful of your unit to have consistent unit. I'm trying to be a little bit more precise on that. And make sure that you use rho, the distance from the center, and see that's your outside radius, in fact. Hope that makes sense. Bye-bye.